Welcome to the Deep Dive. Today we're looking into a plant that, well, it's pretty much globally beloved, right? But maybe a bit misunderstood. Pandan.
Pandanus amaryllifolius, yeah. That amazing smell.
Exactly, that incredible fragrance.
Ah.
Sweet, a bit grassy. You find it in all sorts of Southeast Asian desserts, those green rice cakes. They
Mhm.
even call it the vanilla of the East.
That's the hook, isn't it? The
Yeah,
scent draws everyone in. But the sources you brought us this week, they kind of deliberately sidestep the smell.
yeah, they do.
And they focus on something maybe more fundamental, the actual structure of this plant. It's incredible engineering almost.
Right. We're looking past the flavor, past the aroma.
And trying to understand the, let's call it architectural genius. That lets it survive and really thrive.
Okay, so that's our mission for this deep dive. We want to pull out the most surprising botanical facts from these sources. Forget the kitchen for a minute. Think more like jungle floor survival tactics.
Structure, stability, and
Yeah.
how it actually reproduces, which is pretty unusual.
Exactly. Understanding Pandan's resilience.
And what's really interesting right off the bat, the sources, these gardening notes, they list pandan as super beginner friendly, like one of the easiest plants you can grow.
Okay.
And that tells you something immediately, doesn't it? If a plant needs so little from you, the gardener, it must have some serious tricks up its sleeve, some powerful adaptations hiding in plain sight.
I think that's why those growers' notes felt different. They weren't just about what it is, but how it works. We're used to plants being a bit needy, specific fertilizers, careful watering schedules.
Right, the usual fuss.
But these notes, they really stress how little effort Pandan needs. Minimal maintenance.
Almost grows itself, yeah. Standard potting mix is fine. Doesn't seem to need constant feeding or special fertilizer.
So what's the catch? There must be something.
Well, the main thing seems to be light, placement. It really needs a spot with full, bright sun. That seems key for it to flourish. But beyond that, apparently very forgiving.
It's like a dream for maybe a slightly forgetful gardener.
Or just a curious one. And speaking of curiosity, the author of these notes, they actually started growing it for two reasons. One links right back to that famous smell.
Ah, okay. What was the thinking there?
Well, besides wanting the leaves for cooking, obviously,
Yeah.
the grower was wondering about natural defenses. The hypothesis was, since the smell is so strong and unique to us.
Maybe it repels pests, like citronella from mosquitoes.
Exactly that kind of idea. Or marigolds keeping away nematodes. You figure such a powerful natural perfume must do something practical in the garden.
Makes total sense. Those strong, volatile organic compounds, the things that make the smell. You'd think they'd confuse insects or just drive them away.
No.
Lots of plants do that.
That was the hope, yes. That's the expectation.
But I sense a but coming.
Yeah, here's where we hit our first myth-busting moment. The source is really clear, that anti-pest theory. Pure myth.
Oh, really? So the smell does nothing for protection?
Apparently not. It's kind of a bummer, actually. The author's own plant, the one putting out that gorgeous scent, it got infested.
No, with what?
Mealybugs. The notes say, unfortunately, even been infested with mealybugs in the past.
Wow, mealybugs. That's like the ultimate gardener's nuisance. So much for the aromatic shield.
Right. The insects just don't seem to care about its lovely vanilla-like notes at all.
Okay, so if the famous fragrance isn't its defense, isn't the key to its survival, that totally shifts things.
It forces us to look elsewhere for the real reason it's so resilient, and that, according to these sources, is all about its physical design, its engineering.
Okay, let's unpack this. This is where we get into the defining feature, right? Those aerial roots.
Yes. This is where it gets really cool, botanically speaking. As the pandan plant gets older, it grows taller, sometimes quite tall and leggy.
And then these roots start appearing
Right.
right out of the main stem.
Exactly. Thickened, specialized roots emerging from the stem, often way above the soil level. They become really pronounced.
They do look quite striking, almost
Yeah.
architectural. I always picture them a bit like mangrove stilt roots or maybe those big buttress roots on rainforest trees. Is that a fair comparison?
That's a great visual. Think of them as nature scaffolding. And what's fascinating here is they're not just for show. They have a crucial dual purpose. And both purposes connect directly to why it's so resilient and why it's so easy to grow. These aren't just leftover roots.
So function number one, is it just about holding it up? Stability.
That's the first big one, yeah. Mechanical stability. Imagine this plant, often with a fairly slender stem for its height, growing in the tropics.
Right. You've got monsoons, strong winds, maybe unstable soil.
Precisely. So these roots growing out from the stem, they act as anchors, prop roots, basically.
Ah, so they widen the base of support, not just relying on the roots underground.
Exactly. They extend the support structure outwards and downwards. The sources imply that as the plant gets taller and heavier with leaves, the underground root system alone might not be enough to prevent it from toppling, especially in wind or on a slope. This extra bracing is essential.
That's really elegant. Simple structural reinforcement, like external buttresses on a building.
Nature's engineering, very efficient.
Okay, so that's stability. What's the second purpose? You said it was dual function. This one's maybe less obvious.
The second function is absorption. And this is absolutely key to why it's so low maintenance.
Absorption from the air.
Yes. These aerial roots are specialized to absorb extra moisture and air directly from the environment around them, not just from the soil down below.
Hold on. Absorbing air. That sounds more like something an orchid or an air plant would do, right? And not usually a plant rooted in the ground.
Well, it points to its adaptation to its native environment, which is often humid, maybe even waterlogged tropical conditions. Think about what happens when soil gets totally saturated after heavy rain.
The roots drown, root rot.
Exactly. The roots in the soil can't get enough oxygen. It's called anoxic stress. Kills loads of common garden plants if the drainage isn't perfect.
Okay, so the pandan has a workaround.
It does. Those aerial roots function as specialized gas exchangers. They have tiny pores on their surface, sometimes called lenticels, and these allow the plant to pull oxygen directly from the humid air. It's a critical backup system.
Wow. Okay, I get it now. It's like architectural and respiratory genius.
Pretty much.
So if the soil gets too wet, the aerial roots keep the oxygen flowing. And if maybe it gets too dry, or you forget to water.
They can absorb moisture from the humid air, too. It gives the plant this incredible tolerance, built-in redundancy for stability, for water, and for air.
No wonder it's beginner-friendly. It's practically designed to survive inconsistent care, especially in a humid climate.
That's the takeaway, yeah. Remarkable tolerance thanks to this specific adaptation. It's botanical success defined by structure.
Truly is. So we've got this incredibly resilient plant, master of structure. But the adaptation story doesn't stop there, does it? The sources bring up another huge surprise, how this thing actually reproduces.
Yeah, this was a real aha moment in the notes. The author mentions, growing pandan for years and then realizing they'd never seen it flower.
Which is weird, right?
Yeah.
For a plant grown all over the world, you just assume plants flower.
You do. But for Pandanus amaryllifolius, flowering is technically possible, but it's described as extremely rare, especially in cultivation. It's just not something you see.
Why is that? Does it need specific conditions, or is it just genetically shy about flowering?
It seems to be a combination. Often, cultivation practices focus on leaf production, maybe not pushing the plant to reproductive maturity. And even in the wild, its flowering cycle is apparently quite complicated, often not leading to viable seeds easily. It's just very, very uncommon outside its native range.
Okay, the implications of that are massive, aren't they? For growers, both big commercial ones and just people at home.
Huge. If it basically never flowers or sets seed reliably.
Then you can't grow it from seed. Sexual reproduction is off the table for propagating it widely.
Correct. And that leads to a major consequence. The plant has to rely entirely on vegetative methods. It has to clone itself to spread.
So every pandan plant you buy at a nursery, every bundle of leaves at the market, they're essentially genetic copies, clones.
That's what the sources indicate, yes. An incredible level of genetic uniformity for such a global commodity. Growers have to use techniques like separating the little suckers that pop up around the base.
Or taking offshoots, stem cuttings.
Exactly, those are the methods mentioned. It's all about making genetically identical copies of the parent plant.
Which, thinking about it from an agricultural perspective, even if it did flower reliably, cloning might still be preferred.
Oh, absolutely. For commercial growing, cloning gives you speed, it gives you predictability, and crucially, uniformity.
You know exactly what you're getting every time.
Right. Same leaf shape, same growth speed, and critically, the same level, the same concentration of those desirable aromatic compounds. No genetic lottery involved.
You bypass the whole waiting game for flowers, the uncertainty of seed viability, the risk of getting a plant that doesn't taste or smell quite right.
Precisely. So this really reinforces the main point we've been exploring. What makes pandan so successful worldwide, especially in cultivation? It's not the flowers it barely has, it's its structure and its knack for efficient self-cloning.
It succeeds through its engineering and its asexual reproduction, not really through its fragrance, defense, or traditional plant reproduction.
That seems to be the story these sources tell.
Okay, so let's pull this all together. We've talked about the structure, the roots, the lack of flowers, the cloning. So what does this all mean? What's the big takeaway for you listening?
Well, I think it means Pandan is just a master class in strategic adaptation, its resilience, its toughness. It's not about the famous smell we saw that fails against common pests like mealybugs.
Right.
Instead, its survival, its global success, it really hinges on its physical design. Those amazing aerial roots doing double duty, holding it up and managing water and air.
And then there's the propagation side.
Yeah, relying almost entirely on efficient cloning, which turns out is perfect for agriculture because it guarantees that consistent quality everyone wants.
It's just this incredibly successful plant that built its empire on, well, solid engineering and efficient self-replication, rather than the usual biological methods.
The vanilla of the East is basically sustained globally by brute force structure and cloning.
Amazing.
And maybe that leaves you with a final thought to chew on. This plant, so widespread, so useful, maintained almost entirely through clones. How many other common plants that we rely on, plants in our gardens, in our food supply? How many of them are actually thriving globally because of similar structural tricks or super efficient cloning, rather than the flowers they might technically possess but rarely use effectively in cultivation?
Like, maybe the key to agricultural success isn't always the seed.
Maybe sometimes it's the cutting, the sucker, the structural workaround. It's definitely something to mull over next time you're looking at, say, a mint plant taking over a pot, or rooting a basil stem in water.
A fascinating angle. We will leave you with that thought. Thanks for diving deep with us today.